Hello, welcome to my YouTube channel. I'm solving all the problems from this textbook, Holt McDougal Physics. And today I'm solving the problems from the part work and the worksheet from the page number 156 of this textbook. So this worksheet is related with the work, and let's move to the worksheet. Okay. I hope you can clearly see the question here. See, I will read the question. A tugboat pulls a ship with a constant net horizontal force of 5 times 10 power 3 Newton and causes the ship to move through the harbor. How much work is done on the ship if it moves a distance of 3 kilometers? Yes. So first we can list the net horizontal force, that is F. F net, it is 5 times 10 power 3 Newton. That causes the ship to move through the harbor, and with how much is the work done? Okay, if the ship moves through a distance of 3 kilometers. So the distance it is moved, it is 3 kilometer. And see here, the distance is given in kilometer. So we should convert that into meter because this Newton is in SI unit. So we know that 1 kilometer means 1 kilometer is 1000 meter, or simply it's equal to 10 power 3 meter. So that we can substitute here 3 times 10 power 3 meter. And the work done, we know that what is work done, it is FD cos theta. So what is the value of theta? Theta is actually the angle between the applied force and the distance. So here it is given the horizontal force. So here if the object is moving in this direction, the applied force is also applied along the same direction. So the angle theta here, it is 0 degree, and we know that cos 0 is equal to 1. So the work done simply equal to FD. FD means it is 5 times 10 power 3 multiplied with 3 times 10 power 3. That's equal to 5 3 it is 15 times 10 power 6 joule. That is the work done here. Okay. It's very simple. Just we have to substitute in the relation. In the second question, a weightlifter lifts a set of weights a vertical distance of 2 meters. Okay, there is a person, he is lifting weight in the upward direction. Of course, lifting will be in the upward. So that's a distance of 2 meters with a constant net force of 350 Newton. Okay, the net force applied, it is 350 Newton, that is exerted on the weights. What is the net work done on the weight? So here the net work done, here also that we can find, then FD cos theta. Here also the angle theta, see here, the lifting is happening upward and also the force is exerting in the same direction, upward only. So here the distance and the net force both are acting along the same direction. So here also the angle theta will be 0 degree. So when angle theta is 0, cos 0 is equal to 1. So the net work done will be equal to FD. And here what is FD? What is F here? It is 350 Newton. So it is 350 times 2. So it's around 35 times 2, it is 70 plus this 0. Okay, this is 700 joule. That is the work done here. Okay. So from the same worksheet, there is a third problem. A shopper in a supermarket pushes a cart with a force of 35 Newton directed at an angle of 25 degree downward from the horizontal. Find the work done by the shopper on the cart as the shopper moves along a 50 meter length of AC. So here the cart is moving in this direction and the applied force, it is 35 Newton. Okay, the applied force FA, I'm writing it as FA, that's equal to 35 Newton, and that is directed at an angle of 25 degree downward from the horizontal. That is 25 degree downward. So here if the card is moving in this direction, applied force is downward. Okay, I hope you can see the diagram here I am drawing. Applied force is downward. So this applied force is acting downward. So when we know that when the applied force is not parallel to the direction of motion, in that case not all the applied force will not be used to do work. Only some part of this applied force only used to do the work, because the work is happening along in this direction. So here we can resolve this applied force into, and this angle it is 25 degree. We can resolve the applied force into two components. An x component of the applied force which is acting along the direction of the cart motion, and there is a y component of the applied force which is perpendicular to the x component. And here only this x component of the applied force that is doing some work here, and this y component is not doing any work in this direction. So here Fa, that is 35 Newton, and now we have to find the work done. We have to find, and the distance it is given. The distance it is given as 50 meter. Okay, the distance it is given as 50 meter, and only the x component of the applied force is doing some work here, because that is only along the movement, or along the same direction of the movement. So it is 35 times cos of 25. So the answer is equal to 31.72 Newton. And yes, now we have to find the work done. Work done will be this Fax times 50, and of course the Fax and the motion, this is the direction of motion, the displacement is happening along the same direction, so that is equal to Fax. What's the value? It is 31.72 times 50. Yes, so it's equal to 1586.04 joule. Okay, if you consider this Fay, what will happen here? Fay is actually acting perpendicular to D, right? So of course this cos, of course there is another cos theta comes here. That theta is the angle between this Fax and D, and of course that is 0 here, right? And here Fay and the distance D, if you consider the motion and Fay, they are perpendicular, so the theta will be 90 degree, and cos 90 we know that it is 0. So the work done by this force is equal to 0, and the work done by this force that exists, it is equal to 1586.04 joule. Okay. The last question, if 2 joule of work is done in raising a 180 gram apple, how far is it lifted? Okay, so here the work done it is 2 joule, and the mass it is given as 180 gram. See here the gram is not an SI unit, so we have to convert that into the SI unit, that's 10 power minus 3. We have to multiply with it that much kilogram, because 1 gram is 10 power minus 3 kilogram. So here also we have to find the distance, how far it is lifted. So we have to find the distance it is lifted. So we know that the work done is equal to Fd. See, in this case it is the work done is Fd cos theta, and what is theta that we have to find? Theta will be 0 here, of course, because the force is applying upward and the displacement is also happening upward. But at the same time, here the force that we have to find, the gravitational force that is acting downward. So the amount of force that you have to use to raise the apple should be equal to the gravitational force. So that we have to find Fg. We know that will be the force comes here. Okay, Fg that is equal to mg. m here it is 180 times 10 power minus 3 times 9.81. So it is 1.77 Newton. So how it is 1.77 Newton? Of course this is the force here. Okay, so the work done is equal to 1.77 into the distance. Work done, we know that it is 2 joule. 2 joule equal to 1.77 into d. D equal to 2 by 1.77. So the answer is around 1.13 meter.